All right, so this is going to be a lesson on 4.3, solving for vector components. All right, so we have the simulation here. You have a launcher, a projectile launcher. All right, so you have a projectile launcher here. Right, and I'm going to launch this object, and I'm going to put it in slow-mo, launch this object. And you see here this green line, right? So this green vector here, you see this vector over here. And well, what is this vector? Well, this vector represents the velocity of the object as it goes into the air. Right? So this is my velocity vector, and this is my total velocity. This is my launch velocity. And well, then, as you know, as we learned in the past, right, as we learned in the previous topics, well, we can kind of separate something into an x and y component, right? So we can separate this velocity vector into an x and a y, right? Which is what you see over here. So I separated this vector right here. Right? I'm going to actually draw this. I separated this vector into its components, right? So this vector right here has a vertical component, right? So it has this velocity vector as the object is going up has a vertical component, right? As you can see in the simulation, right? So there's a vertical, and then there's also a horizontal component, right? Which we call really just your Vx, right? Your horizontal velocity. So that take care of that. Well, and then again, this would be my actual velocity, my total velocity. Right, so again, to reiterate, we can separate this velocity vector into an x velocity and a y velocity, right? Those are our components. Well, how would we solve for that, right? How would one solve for, how would one solve for any one of these sides? Well, if we're given two of these sides, we can actually solve for the third. And how would we do that? Well, first off, we have to kind of make a triangle here. And how am I going to make a triangle? Well, I'm just going to move this vector right here. Well, I'm going to move that y velocity vector. Right, I'm going to draw it over here. And so this would be my y vector. So again, you can see that, well, now we've just made a triangle, and then as long as we have any two of these sides, well, we can figure out the third side. And this concept should be familiar to you guys. Well, that's because that's known as the Pythagorean theorem. It's known as the Pythagorean theorem. Right, so we have two sides here, as you can see, right? We have two sides. We have, we're going to call it our hypotenuse, and we're going to call our hypotenuse A, right? That long side there, A, that's going to be essentially your actual velocity. And AX is going to be a horizontal vector, and AY will be a vertical vector. Right, so this is essentially all your components combined. All right. And so let's go to a practice problem here. Go to a practice problem. So we have a projectile here. It's launched at an angle above the ground. And it says that, well, the horizontal component of the projectile's velocity, Vx, is initially 40 meters per second. Right, so this is AX. Right, this is my horizontal velocity, my horizontal component, right? So the horizontal component, Vx, right, is 40 meters per second, right? And if I were to relate it to this triangle here, well, that would be AX, right? So this would be AX, 40 meters per second, right? That would be AX. And we have here, well, my vertical component of the projectile's velocity, Vy, right? So the vertical component, Vy, would be essentially AY here, right? So that would be this side. That would be my vertical component, right? That would be my vertical velocity, which is 30 meters per second here. And then the question says, well, what is the velocity the projectile was launched at? Well, that's what they're saying here. They want A, right? They want the velocity object was launched at, which is A, and so you don't know A, right? You don't know the velocity. Again, so essentially going back to the simulation, you're given these two components. You're given that vertical component, right? And you're given the horizontal component, right? You're given horizontal velocity and vertical velocity. And you're asked to find out, well, what is my total velocity? What is the launch velocity here? What is this green vector? So that's essentially what you're being asked, right? You're being shown, you're being given your two sides, and well, you're asked to find out your total velocity. So all we need to do here, guys, right? So we're gonna do the Pythagorean theorem is a squared, ax squared, right? A x squared ay, right? So a is right 8 squared, and then ax squared is 40 squared plus 30 squared. 40 squared is 1600. 30 squared is 900. So you add these together and you get 2500. And then, well, now we have the square root because we need a by itself. And we get 50 meters per second, right? Because that's a unit for velocity here. That's 50 meters per second. And that will be my initial velocity. But let's say it's not so easy anymore, right? Let's say, well, instead of being given two sides and me asked to find the third side, well, what would happen if we were given an angle and, I don't know, one of these sides, right? So what would happen if I was only given my launch velocity and only my angle? Only two of them. Well, we have to use trigonometry here, right? We have to use actually these two formulas, right? We have to use these two formulas here. So again, your AY is your vertical, and your AX is your horizontal. And your A is essentially your launch velocity, right? So AX is your launch velocity. And so you can find these two formulas on your reference table. On your reference table, it's right below VF squared is equal to VI squared plus 2AD. Actually, I should probably show you, right? That would make a lot of sense. So let me just bring it up. Let me just bring it up. So now we have this, right? So let's go to the back here. Right, so here I have this, right? So this is your formulas are over here, right? So these are your two formulas right there. Okay. So let's do some practice problems, right? Let's do some practice problems. A golf ball is propelled with an initial velocity of 60 meters per second, right? So essentially this would be my launch velocity, right? I'm being launched at this particular speed. Right, so I'm being launched with initial velocity, so that's going to be my hypotenuse. So A is 60 meters per second, right? That's my launch velocity. And I launch at 37 degrees above the horizontal. And so the horizontal component of the golf ball's initial velocity is 1. And so here they're looking for AX, right? They're looking for your horizontal component. They're looking for your horizontal component. So which one of these two formulas should I use, right? Should I use the sine one or the cosine one? Well, I should probably use the cosine one because it has everything I need, right? I'm solving for AX, I'm solving for A. Well, I have A and I have the angle. So I should use that formula. So all I'm going to do now is I'm going to plug I'm going to substitute everything in, right? So I'm going to do 60 cosine 37 degrees. And we just plug this into our calculators, right? Make sure your calculators are in degrees and not radians, because if it's in radians, you will get the wrong answer. Make sure it is in degrees. And so here I get 47.9 meters per second, right? Because we're looking for the horizontal component of the velocity. So for B, we'll do the same exact thing essentially, right? It says a golf ball is hit with an initial velocity of 15 meters per second. So it's being launched at an angle, right? At an angle of 35 degrees above the horizontal. So this essentially is my launch velocity. So this essentially is A, right? So that's 15 meters per second above the horizontal. So your angle is 35 degrees. Right? And the question says, well, what is the vertical component of your ball's initial velocity? So here they're looking for AY, right? They're looking for AY over here. So which formula should I use? I should use the sine one because again, it has everything I need, right? So AY is equal to A sine theta. So AY is AY, A is 15, and then your angle here is 35 degrees. So 15 sine 35, do I remember based on memory? I think in class I said it was 8.6. Let me just, yeah, it is 8.6. So we get 8.6 meters per second here. Again, make sure you're using degrees. Make sure you're using degrees. All right, let's move on. And again, if you didn't catch that, I would definitely rewind the video, right, and pause for a brief amount of time, however much time you need. So a baseball is thrown at an angle of 40 degrees, right? So here you throw an angle of 40 degrees here, right, above the horizontal. And the horizontal component of the ball's initial velocity, right? So they're saying that AX here, right? AX is 12 meters per second. And then, well, then the question goes on to say, well, what is the magnitude of the ball's initial velocity, right? Which is what the A is, right? They want to know, well, what is your launch velocity? So what is A there? So AX is equal to A cosine theta, right? 12A cosine 40. I know some of you guys are going to be like, well, I should probably fill out cosine 40 first. But what I'm going to have you guys do instead is actually, we're going to divide cosine. Again, this is a multiplication here, so we should get rid of this through division. So we're going to divide cosine 40 on both sides here to get rid of it. And now I have A is equal to 12 cosine 40. And now you guys should plug it into a calculator. Now you should do 12 divided by cosine 40. And this just makes things a little bit simpler, so you're not doing multiple steps. And what you guys should get, right, the answer you guys should get is 15.7 meters per second. And that's how you would solve for these type of problems, right? But let's say now, let's move on to the next part, right? So let's say now the question is asking you to solve for the angle. What will we do there? So the easiest way to show you is, well, let's go through a problem first. Let's go through one of these problems. So a projectile is fired with an initial velocity of 120 meters per second, right? So you know A, right? So you're launching with a velocity of 120 meters per second. That's your launch velocity at a certain angle above the horizontal. So again, you don't really know the angle here. The question then goes on to say, if the projectile's initial horizontal speed is 55 meters per second, right, AX is 55 meters per second, then the angle measures approximately what? So here you're looking for your angle. But before that, before we get into like solving our angle directly, we have to figure out, well, which formula should I use? I'm going to use the second one, right? Because, well, we have AX, we have A, and we're looking for angle. So we are going to use the middle formula here, right? AX is 55, A is 120, and cosine theta. So you're going to divide these two by 120, right? So you're going to do 55 divided by 120. I'm going to keep this as a fraction for now, right? Because again, I want to show you an easy way to do this. Is like to reduce the amount of steps you need to make. So I need to get this angle by itself. I want to get theta. I want to get the angle by itself. I want to get rid of this cosine. How do I get rid of a cosine? You might remember from trigonometry. You have to actually multiply both sides by cosine -1. The cosine to the -1 gets rid of the cosine. But we also have to multiply by cosine -1 on this side as well. So our data here is equal to cosine -1, right? 55 divided by 120. And we get 62.7 degrees. And that's our answer, right? That's the angle. That's our angle. That's the angle the ball was launched at. All right. Let's do the last practice problem. I'm going to do the same exact method here, actually. So projectiles fire with an initial velocity of 80 meters per second. So again, A is 80 meters per second here at a certain angle above the horizontal. And the question says, well, at the projectile's initial vertical speed is 45 meters per second. Well, then the angle measures approximately what, right? So here you're looking at this and this, A sine theta. So A y is 45, A is 80, sine theta, divide this by 80. Right? So that's a sine theta right there. Again, well, how do I get rid of this sine? We'll have to multiply both sides by sine -1. And multiply both sides by sine -1. And then I got, well, I don't know what the hell that was, but so theta is equal to sine -1, 45 divided by 80. And we should get 34.2. We should get 34.2 degrees. And that's our data. That's our answer. Again, if you need to look over some things again, for sure, just rewind the video. Okay? All right, we're good. Okay.